Need search this week? Not a quarter-long info project? We'll build hybrid full-text plus vectors in Postgres, so you can ship semantic search without a new cluster. If your search returns wrong things or needs too much info work, this video is for you. You will learn a compact pattern that lives inside Postgres, mixes lexical and semantic signals, and gives useful, ranked results you can tune. No new cluster, just one database and a small embedding step. I'm Professor Pi, teaching search and IR from basics to advanced with simple, concepts-first Python that helps you solve bigger real-world problems. Hybrid search solves a concrete pain. Full text finds exact words and filters fast. Vector search finds similar meaning and recovers paraphrases. Together you get both precision and recall. For small to medium collections, this is a production-ready pattern. We will use a tiny toy corpus of 2 documents and 3-dimensional embeddings, so you can see every piece clearly. The intuition is simple. Store embeddings alongside text. Use vector distance to score meaning. Use full text matches to reward exact hits. Then blend those scores with a weight you control. The result ranks documents that are both relevant and semantically close. We will build this step by step in Postgres using the pgvector extension and psycopg. Create a small table, insert 2 rows, run a pure vector match, run a filtered hybrid match, and produce a ranked list you can deliver from a single SQL query. Now we enable Postgres extensions and check connectivity. This snippet enables pgvector and confirms a working Postgres connection using psycopg. We open a local connection with psycopg, then call create extension if not exists, vector, to ensure the pgvector operators are available. A tiny select OK round trip verifies connectivity and transaction behavior are healthy. The variable OK captures the returned literal so we can print a deterministic signal. If this fails, fix connectivity or extension installation before proceeding to indexing and search. The printed ping value confirms your session is ready for hybrid search work in one database. Next, we create a tiny documents table and seed sample rows. This snippet creates a compact docs table and seeds 2 items with tags and embeddings. Using psycopg, we drop any old table to keep results deterministic, and then create table D with a text title T, a tag G, and a 3D pgvector column E. We prepare 2 short tuples A and B, where E is passed as a pgvector literal string, like 0.1, 0.2, 0.3, that Postgres casts into the vector 3 column. A single insert adds both rows, so future queries have something to rank. The printed row count signals that test data is in place for the next steps. Now we run a pure semantic nearest neighbor query to see vector behavior. This snippet runs pgvector nearest neighbor search and returns the top title. We define Q for the natural query and QV as its embedding literal. Then order by the cosine distance operator on the vector column E. Using psycopg, the execute call sorts ascending, so smaller distances rank higher. And ID ASC breaks rare ties deterministically. The variable T captures the highest scoring semantic match from table D. If your QV drifts toward another item's direction, the top result will flip accordingly. Tighter QV alignment reduces distance and improves rank. The printed title shows the best pure vector match. Next, we add a tag filter and mix in a full text signal to prioritize exact matches within a category. This snippet performs a hybrid rank in Postgres with a tag filter using psycopg. We restrict rows to G equals psych, then combine 70% vector distance and 30% full text signal via a case that rewards 2ts vector of the title matching 2ts query of Q. The execute call orders by the weighted score, so documents that are both semantically close and textually relevant rise. The variables qv and q are reused from earlier steps for consistency. Increasing the 0.7 weight favors semantic matches. Decreasing it rewards stricter text hits. The printed title shows the best cycling result after blending both signals. Finally, we build a simple ranked list output you could return from an API. This snippet returns a tiny baseline list by sorting all docs with a hybrid score. We used psycopg to compute a 60-40 blend of vector distance and full text match. Then string ag orders titles by the combined score into a readable bar-separated list. The parameters qv and q drive semantic and lexical relevance without leaving Postgres. You can tune 0.6 versus 0.4. Raising the first improves semantic recall, while raising the second tightens lexical precision. The printed pipeline result is a ranked, ready-to-ship baseline you can filter or paginate. This small toy maps cleanly to a real app. Replace the 2 rows with your FAQ or product list. Replace the 3-dimensional vectors with 768 or 1536 dimensional model embeddings, and expose the final query as an endpoint that takes a query and returns ordered results. Keep the blend weight as a configurable parameter in your service so business logic can nudge precision or recall. Recap what we built: a single Postgres table with both pgvector embeddings and full text data. When to use it: when you want semantic recall plus lexical precision without a separate search cluster. One caveat: tuning weights matters. Blended scores can hide poor embeddings or noisy text matches. Next step: tune the semantic versus lexical weight in the hybrid score and measure how recall and decision change on your real queries. Small changes will shift ranking behavior in predictable ways and tell you whether to favor vectors or text for your use case. If short, practical IR helps, subscribe and watch the IR videos.